All right, we're going to do number 16, chapter 3. And in this one, they give you these two vectors, vector A, vector B. They're already in vector notation, which means the components are already done. We don't have to take the components because this is the x component, this is the y component, this is the x component, this is the y component. And then we have vector F, which is a combination of vectors A and B. And they ask us, there's actually three different parts to this problem. They want vector F in component form. So part A is F in component form. Part B, they want us to draw the vectors A, B, and F. And for part C, they want to know the magnitude and direction of vector F. All right, so for part A, F in component form, this is very easy because we have F is equal to A minus 4B. Well, this is easy because we know what A is. A is 4I hat minus 2J hat. And then this is minus 4 times B, which is negative 3I hat plus 5J hat. And so now all we're going to do is we're going to distribute the negative 4. So this is 4I hat minus 2J hat plus 12I hat minus 20J hat. Now the key here is remember these are x's and these are y's. You can't combine x's and y's. They have to be separate. So the I hats you combine. So we say 4 plus 12 is 16. So we end up with 16I hat minus 2 minus 20 minus 22J hat. That is vector F. All right, and then we want to draw this. So over here, I'm going to just draw my coordinate grid. And notice it's got to be pretty big here. So I'm going to do this in groups of 5, 10, 15, 20. So this is 5, 10, 15, 20 this way. Negative 5, negative 10, negative 15, negative 20, negative 25 going this way. All right, and so the first one, I should complete it here. This is 5, 10, 5, 10. Try to make it equal. So for vector A, we go 4 over and negative 2. So vector A is going to go like this. Vector B is negative 3 in the x direction, so it goes negative 3 this way, plus 5. So vector B is going to be like this. And vector F, on the other hand, is going to be 16. So I go over to 16 and down to negative 22. So 5, 10, 15, 20, 22. So about here. So that's going to be vector F. Okay. Now I want to know, so that's part B. Part C, the magnitude and direction of F. So I need to know how big F is. Well, I have the components. I have Fx and Fy here. So to get what F is, I use a Pythagorean theorem and just say 16 squared plus 22 squared and take the square root of that. And that gives me the magnitude of F. The magnitude is 27. And I think they gave, if they don't tell you we use standard units, that would be meters. And to get the angle, theta, we're going to do y over x. And so in this case, it's going to be inverse tangent of, and notice I'm taking the absolute value here. I don't do the negatives in there. I just figure out, I just put them in as absolute values, and then I'm going to figure out where the angle is when I'm done. So I take the inverse tangent 22 over 16 and I get 54 degrees. But then I have to figure out where it's 54 degrees. Well, what I did is I made the y the opposite side, right? So y direction, the 22 is opposite. 16 is adjacent, which means the 16, I made a triangle like this. So the x component is adjacent and the y component is opposite, so I figured out this angle here. So I would say 54 degrees below the positive x-axis. You must have this on your answers to be right. You have to tell it where it goes, what the reference point is. I could also say that this is 36 degrees, right, to the positive x side of the negative y-axis. So I could say this angle here would get me the same direction. So there are multiple ways to say this angle. All right, and that's how you do number 16.